Today we're going to build two interfaces to the Clock Punch contract, which we've already built and deployed. Again, it's quite simple. I guess I'll just open up the code here just so we can have that contract on the screen. But just an event emitter. And the first thing we're gonna build two interfaces here. We're gonna build a web page with Web3.js, which we've done a couple times already in the CPA session here, and then we're going to move on to the Python script, which hopefully third time's the charm here, but we'll see how we do here. But this first part, building the web page, I'm going to sort of make it a game here and just see how quickly I can do it. This will be a little bit of a blitz, and I haven't started this interface at all with the JavaScript interface. So yeah, just to go through what we'll do, we're going to list all events from the contract, which we've used events before, but they've been in relation to factory contracts. So this will be, this first item will be interesting to anybody who wants to use events in a more, more normal way, a more common way. Then we're going to start, after we list the events, we'll start filtering out for specific types of events, and we'll end by tallying in and out actions to output an hours worked value. So that's what we will be doing today, or at least for the first half of this. So let's, I guess let's jump right into it. I'm going to make a new file here. I'm also going to go ahead and now I'm going into my web docs folder, and I am going to go to week 4. And it's in the web docs just so I can actually load this in my browser. But we're going to make another directory. It's going to be whoops. Okay. Now this one we're just going to save it. Well, actually, I'm gonna take from week 3. I'm going to copy this CSS folder. Whoops. So I'm just using the subscription manager interface from week 3, and I'm just going to plop it right into our new folder here. Paste. I don't have a mouse, so might be stumbling around here. I'm also just gonna take a look at this one, copy it and paste it into our own and rename. Well, it's still going to be index.html, but it's going to be in our folder here. Okay, now let's go look at the dependencies here. So it's going to get the CSS, which we've just put in there. Then it's going to grab a bunch of stuff from the CDNs. Then it wants the contract info.js, so let's make that really quick. Now it keeps trying to save in this other folder, so I'm going to remove that. And remove this guy too. Okay, now we're closer to where we should be saving things to. It's still a little weird here. JS and well, we'll just make another full file here. Index.js. Okay, so we got all the files we need here now. Let's get the contract info put in. So I'm going to get the, oh, I need to compile it here, I guess. And this is going to give us a different ABI because I changed these indexes. I removed the index. I'm gonna remove all the indexes here, compile and redeploy. So let's go to run. Gonna do it all in Ropsten. Okay, there we go. Let's get the ABI here, and let's also deploy it. And when it's done deploying, we'll grab the address from it. Wait for that to come in. And index, I'm gonna take a look at the index here, and I'll probably copy some of this anyway. And we do still want a, well, this is all under the window.onload. And we'll start the view instance as well here. Really should get a template up so I wouldn't have to do all of this every time. Okay, and let's go to the HTML now. So these first, we're going to keep the warnings here, so we can keep those up. We're going to take out a lot of the interface here. We're not creating a wallet. We will need an address input, but we can put that in later. And then this is all just conditional displaying of different wallet interfaces, I believe. And then we can keep this transactions div here. Okay, so that, I think our HTML main page is ready. And our contract info will be ready soon. This, we probably want to put a little bit more in here. Let's see what the other index.js has. Don't need the wallet types, user address output, network ID output. We can have those two. I don't know where those came from. Transactions, we'll need that, and I think that's it. Okay, now I just want to test it and make sure it all loads. Of course, it's not going to load because our contract info doesn't have a address yet, so let me see if that was been mined. Let's go here. Oh man. Okay, well at least it's on there. Oh, it gave it a small gas price again. frustrating. At least they do give you the option to redeploy with a higher gas price. That was not available for a while there. When it redeploys, it deploys the transaction with the same hash, I believe. Oh no, a different hash. Anyway. And I don't even know if increasing the gas prices matters, because we're on Ropson. Sometimes I'll choose to develop on mainnet knowing that I'll spend more money, because I know that they'll actually have a better chance of getting included. Sometimes Ropson is really fast, but sometimes it just is not fast, so I guess we'll give that a second here. Let's just go and see if my page loads. I'll just make this empty for now, and go to my local host. We're going to go to seminar source code. Week 4, Clock Punch webpage. Okay. Right, I need to, so this is coming out because view, I don't have the, well, actually I'm not sure why. Let's go look. I guess I should close. That's our old one. That's our old one. So now we have only new files open here. So index, transaction object string. That's interesting. So I have this v show here. If the transaction's length is greater than 0. So this whole thing, the transactions shouldn't even be broadcasted right now. I'm probably getting an error in the JavaScript, and so the view is not initializing correctly. No, interesting. I've called it app here, and it's looking for app there. I guess another thing to check is to see if it's undefined. That should be defined right here. It's interesting. Okay, I'm making the app, and I'm telling it where to find the element in the HTML. I'm telling it to find app. So on index.html, it should be looking for this, and then applying the, well, it should be transforming this, and it should also be hiding the whole element. But it's not. It seems almost like it's not loading view, but it sure is right there. Oh boy. I mean, we are getting this. This is actually running, right? I wonder if it's not even running. Okay, so our JavaScript isn't even running. I wonder if this is not supposed to be a capital. Okay, there we go. Alright, what a rookie mistake. Okay, we're back on track now. Let's see. Okay, I'm getting my warnings correctly now. That's good, and it's hidden the thing. That's also good. Is my transaction mined? It is. Okay. So at least I'm not having the same issue I did as yesterday, where my MetaMask was not working. Now let's go ahead and plop our address into contract info. And this time I'm just going to put a, whoa, lots of messages on Slack. What's going on? Oh my goodness. Thanks, guys. I hate this. My sound card is getting worse and worse. I don't even know if I can get it to work. The light's not coming on anymore. Fuck. Okay. I got the light turning on again, so we'll see here if this lasts. Okay, that should be better now, right? Yeah, okay. Goodness, okay. So first thing I want to do is list events from this contract. We also want to actually load the contract. We haven't done that yet in the code. Now in our last one, computed. Yeah, we had a computed contract. Yeah, sorry about that, guys. Okay, so I'm gonna have a computed item in our view here. And it's going to be the contract instance. So our okay, let's just see how we did it last time. We had a function. Yeah, that's fine. And now we want to Web3 ETH contract with the ABI at the address. And I should probably rename this like that. Save, go over to my contract info. Okay. So we should have that computed. I'm just going to run it and see if we get any errors. Do you have an error? Syntax error on 11. Got no arrows, that's good. So we got the contract loaded. Now, I guess the next thing to do is to scan for the events. So let's see. Let's go ahead and I guess right when it loads, it should scan. So we'll just put it right at the end of this function. Well, I'll define the function, but call it here. So the function will be called, let's see, get all punch events. And then it's going to take the all right. Let's look at how do we fetch events now. Whoops, not Web3 Pi. We're not dealing with that yet. That's Okay, I just need to go to these docs right here. Old Web3.js docs. Yeah, that's pretty simple. Okay. I'm going to call this event filter because it's really a filter. It's not an event. And then we need the name of the event, which is punch event, like so. And then we can give it a filter if we want. I'm not going to do that yet. So I'm just going to leave that empty, like so. Okay. Yeah, so now we do need to set some filters here, because I want to make sure we have the from block and the to block. That's what we want to do. So if we go back here, so we have this additional filter block. That's where we're going to put in our from block and to block. And I'm going to do 6 million because that's a sort of recent block lately. To block latest. I think this is actually the default value. If you don't specify a to block, it'll just assume you mean latest. Okay, and then I believe we can just do this now and get the result. Oh, let's do filter.get. That'll be the good one to do. And I just need a callback. And this is going to be error result, as with all the Web3 callbacks. If error console.log event fetch. I'm just going to log this for now. Whoops, log res, just to see what we get out of this. And okay, now that I've defined that, let's actually call it. Filter is not defined. Oh yeah. Okay, I'm getting an oh well, I'm getting an empty array because this is a new contract. Of course, there's no events on it yet. Okay, so that's fine. I'm just gonna go, and the easiest way would be to go to get this address here, put it into remix, load contract from address, do that, and then I'm going to call the punch action with an in. It doesn't really matter what's in there now, but let's just do that. Now, unfortunately, we'll have to wait for this to go before we can try to scan for that event again. But that should work. Okay. When we get that back, let's just look at the structure of what that's going to get us. Watch callback return value. Filter. So we're going to get, I think, a list of objects because we're watching for many events. Yeah. We could also do an all events here to do a similar thing. Okay, that's been mined, and we can see that there's one event here. So now if we go back and load our page, we should see that. Nope. All right, well, that's great. Jesus. I did put in the right number here, right? Oh, we're on Ropsten. So this actually needs to be a different number. Okay. Because Ropsten is not nearly as big as mainnet. So let's do 3.7 million. Like that. That is 3.7 million. Okay. There we go. Now we're getting some. So now we have a list indeed, and yeah, we have the args here. So we have an in for the action, and the agent is the address. So that that looks pretty cool. All right, that's good. So now the ultimate goal here, if we go back to the outline, it eventually is a tally time between in and out actions. So rather than trying to output the list onto the web page, I'm just going to start massaging this list, and I'm going to do 2 and 3, and we'll just be working with the log output, the console log output. So let's see. I am going to now, I'm going to go back to my interface and give it a little bit more data. So first I'm going to do a log out, all right, punch out, and submit. Now I'm also going to do a string that's just gibberish, to that way we'll be able to see if we can test, filter out anything that's not in or out. And now I'm also going to change my Web3 account and do this from a different, let's do test Alice. And let's see, what is her address? It is 3420. I suspect I have to change it here as well. Nope. Okay, it's going to make me reload the page, so I'll do that. Copy that, reload. Give it a second. Run. Okay, I need to compile it again. Now I can run, put it at the address here. And now it's going from my Alice account. So now I'm going to do one more thing, and I'm going to say in, so that way we can see if we can filter that in later. Filter that out later. Yeah, the event filter function does go through MetaMask. So MetaMask, in this case, when you're using these event filters, is your liaison to the Ethereum network. And that's the only way that you can, all of this Web3 functionality, except for functions like translating between units like Web3 two-way, but every Web3 function that gets information from a contract, even if it's just events, they all depend on, well, they depend on a provider. And the by far the most popular provider is MetaMask. So yeah, if you don't have MetaMask, you need something else, maybe a node running on your machine or something like that. But yes, the event fetching stuff depends on some kind of provider. Okay, so let's just see how these transactions are doing. Okay, so it looks like that one went through already for Alice. and for main. So those are all done. So now if I just reload this page, we should see a bigger list get logged here. Okay, that's good. So we have 4 events here. So the first thing we want to do is filter out, well, we need to do 2 things. We need to filter out everything that's not an in or an out, and we need to also filter out the for the specific address that we want to watch. I'm going to do the address filtering first, and we'll actually do an input here on the page. So let's go ahead and we'll go to the HTML here, and we want it before the transactions. Oh, but we do want it in the app, of course. And this is just going to be an input to, I'm going to look at how we did the input in the previous. Got buttons, button, input v model. Okay, that's pretty easy. In fact, I'm just going to copy this line, because we do want an address. Okay, address input v model, and now this is we're gonna change this. Agent address input, input, and now we need to go and make sure that that is in our app. Like so. Okay, let's just see if it shows up correctly. That is not really what I wanted. I need to do a little bit more scaffolding here. I need to put a row. Need to put a main block. That's going to change our CSS styling, and then also make a well. And these, what I'm doing right now, are from the Bootstrap. The well and the well small. Goodness. Okay. Let's see how that looks. Must have missed something. It looks like I missed a quote. Oh, here we go. I missed a class equals. Almost there. Why is my address way over there? I don't know. I really don't know. Wonder what happens if I take this out. Nothing. Okay, I'm not going to worry too much about it now because we only have 20 minutes left. I'd like to get to the functionality. So we have this input. It's going to change our agent address input here, and then the only thing we'll need to do then is have when our, let's see, get all punch events, we'd like for that to trigger let's make a button for it for now. Get all punch events, yes. Let's see, do I just put the name in the button tag here? Yes, I do. So that's fine. Got the button. Can make the button look better, but not worried about it now. Now we just need to change the function here. And the only thing now to do is to, now this first dictionary, which we left at empty, this will let us, should let us filter based on an address argument. So we should be able to say agent and then put in our window.app.agent address input. Yeah. So let's try that and reload it and see how it goes. Now first it should log an empty array. No. It's giving me 4, which is interesting because right now agent address input is empty, so maybe it takes an empty string as anyone, but let's try taking now, let's get my, yep, on my main, that's good. Copy address, paste, and do this. Nope, still getting 4. Oh, this is out of date. I need to change this. We took these out. Save that. Interesting. Okay, well, I was hoping that would work. Maybe I'm doing it wrong. Let me just double check. Oh, right. I need to... this should not be a string. Let's try that. Interesting. Our filter there is not working. Okay, well, that's fine. I mean, it's not fine, but I am just gonna do it in the code here. I'm gonna make another, I'm gonna change the structure. This shouldn't be logging it. It's gonna return the result. And we're making another function. Okay, now what is the structure of this exactly? So we have a list of objects, and each object has an args, which has a dictionary. So args and then a dictionary. Agent equals Oh wait, no, we don't need that. We can just do agent address. Rename this to be a little bit clearer. Okay, let's see how that does. So we're getting an undefined logged. That's interesting. Oh, it's because we're returning inside an anonymous function. That's why. So it's not gonna work quite like that. Oh my goodness. Okay. Let's try that. Undefined still. Okay, what I'm trying to do here is I want to get the punch events from agent. This would be easier if I had somewhere to store it. So what I'm going to do is I'm going to go to the view here, and we're going to make another one, another variable, and it's going to be a list called punch actions, and rather than having this all split up, I think I'm just going to take all this and put it into one function here. Like that. Event filter, let's see, and we don't want to return result. We want to say like so. I guess we'll say all punch events. And then instead of returning this here, I'm going to say just window.app. What did I call it? Punch actions. Oh, actually, I could just do it all right here. Okay, let's just see if it populates the address. Nope. Oh, because I don't call this. Need to actually call it. Which I can do with the button. Whoops, that's not what I want. Go away. Let's refresh. Let's get my address. And I have an error as well. Get all punch events is not defined. Line 46. Right. We don't need that here anymore. Okay, refresh. Let's put in my address. Hit this. Okay. On click is going for the wrong address or the wrong function name. Okay, I'm going to keep it as taking no arguments, and here I'm going to take this out and instead do an address input. Nope, need my address again. Error. All punch events is not defined. Does that? It should be. Does that mean we got an error? I don't have a log. Oh, it's because it's setting this once again in this anonymous function here. So we're setting all punch events here, but it's getting lost. I don't think this will fix it. I'm just going to try it. I believe that won't really do anything though. Won't solve the problem. No. Oh, cannot read property length of undefined. Yeah, so it's just undefined. And well, one thing we could do to alleviate this is just do that. And then we can say here window dot and put that in front of all of our references. Get my address again. Still not working. Is it back to the bad? Turn in the anonymous function and set the event filter to a new variable. Oh, okay. Like so. That seems like that would work. Okay. Not doing anything now. Oh, well, it should now have populated. So we don't get an error. That's good. Now we just need to see app dot punch actions. Nothing seems to have been put onto it. So even when I click this button and I run this, it doesn't seem to be going through this at all. All punch events, I guess it is finding that it's empty. All punch events, so it's returning it's not returning the result. Yeah, maybe, maybe I can, why doesn't this one work? All punch events is not defined. Oh, but that's in line 62. I already tried this before and I don't quite remember what it did though. Yeah, it's just this is confusing me because it's saying that it's undefined on 62. Window.allpunchEvents.length. That should be a list though, but it's saying that it's undefined. I guess maybe it's maybe the garbage cleaning is deleting this variable. Okay. Okay, let's just try array.slice. And copy that. Oh, it's running our line 60 here. See, it gives us the output from line 60 before it gives us the output from line 55. So that's what's happening here. We're defining a callback and passing it off to eventFilter.get, and it is assigning it. Okay, so this isn't a problem here. I'm going to take this out. The problem is that this callback is executing after our code down here goes. So I guess a quick way to fix that would be to take all this logic and just put it right up here in the callback. It'd be more elegant to do this with promises in JavaScript, but you kind of have to home build your promises if you're going to be using them in Web3. But I bet that'll fix it right there. And let's take out this console.log. Put a semicolon here. I bet that'll do it. Let's try it. My address again. Okay, now if this works, we should punch actions. it's just an observer still, and with length 0. We're getting this console.log, but I guess it's not. Well, maybe this is always failing. All right, I'm gonna just do a little bit more troubleshooting and then end the stream here. Actually, let's just see if this window.allPunchyEvents, let's see what it is here. Whoops. Okay, that's 4 long, so it should be iterating through. Let's take the first one, .args agent. Oh, you know what? I bet there's some caps mismatch. Yeah, there's some caps mismatch. So that's the problem there. Okay, well, we can fix that. Two lowercase, pretty easy. Okay, I'll check that. I'm getting some messages. I'll check them in just a second. Hey, there we go. So I think it worked. Okay, there we go. We filtered out the other person. So now we have a list, and I'll end the recording in a second here, on the seminar in a second. But now we have the list of 3 objects, and they're all from the specific address that we've put in here. So the next thing to do, which I might just do on my off time, is to filter only for in and out actions and tally the time between in and out. And then, of course, we didn't even get to number 2 here. All right, that's it for the seminar today. Thanks for joining in. Sorry it was a bit slow, guys, but thanks. All right, I'll see you guys next time. Oh, today is a 2-hour stream. That's right. Oh, man. Okay, you guys ready for another hour? I totally forgot that was the plan. Okay. Let's keep going. That's good, because I don't want to stop with things right yet. We can do more. Okay, so the next thing we can do is iterate through, find every in, and then find the next out and tally up that total. That should be pretty easy. Let me just clean up some tabs here. Oh, we can take a break though. Let's do that. Let's go ahead and take a break. We can make it. We'll rejoin it's 19:05 now. Let's. Do you guys want a 5-minute or 10-minute break? Doesn't matter. I'm gonna just say 10 minutes. Unless you all tell me that you want to do 5. So we'll be back here at 19:10 or 19:15. I'll post in the seminar chat whichever one we decide to do here. But yeah, we'll take a break, and when we come back, we'll be hitting number 2 and number 4 of this first big major item here. All right, so time has come. Let's, here we go. All right, so I think, whoops, don't know what I did there. This next bit should be pretty simple. And I think I'll just do it right in the same function, although it would be good to maybe change the function name because I'm adding more functionality than just getting the punch events. I'm not going to worry about that now. What I'm going to do here is I'm just going to iterate through this list that we've generated, window.app.punch actions, and then I'm just going to look for the first in, look for the next out, look for the next in, look for the next out, and tally up the hours that way. So let's do total hours, and we might run into a little bit of difficulty getting the transforming the block number into a time. So in fact, I'm just going to go ahead and find that really quick. Maybe I should have been doing that on the break. These events, they store the block number, they don't store the time, so you need to actually use callbacks and stuff to get the time from the block number. And that might be complicated because we're iterating through a list here, and we'll be using callbacks, and we're going to have issues with returning values and things like that. Well, first, let's just see about getting the time from the block number. I know I did it in Toasty Coin, so I might just go look there. Get transaction hash will contain a block number. Yep. Oh, get block. Yes. So this is what we'll be using, web3eth.getBlock. But we're going to have to use it as a callback. And that's what's going to make this a little complicated. Let's see, I might have solved this problem in Toasty Coin. I'm just going to go take a look. Oh wait, this is the website. I want to go to GitHub, derivative, Toasty Coin. No, not in here. Fuck. Yeah. So this is a component that just takes the block number and the timestamp. It's not really what we want. I don't think this has anything. Yeah, okay, well, yeah, we need to get the time from the block number, and that's going to involve using this web3.eth.getBlock, which is going to involve a callback. And if we're iterating through this and getting the time from each block, we need to figure out how to get that anonymous function that we're going to pass to the callback to assign the time to the right block number, or keep track of how it's returning that. We could promisify it. We could turn it all into promises, but that is something that I haven't done a lot of. I'd hate to stumble around on the stream and be, fiddling with promisifying the whole thing. As I said, that the library Web3 should be using promises, but it doesn't. And if it did, that would make things easier. I mean, we can get the number of blocks between the clock punches, which, I mean, that would be almost like a time, but and I guess then you could use this to then you could use it to like pay someone for the number of blocks during which they've worked on something, but that seems a bit weird. Is there really? Okay, you know what? One thing that we could do is we could actually just add the time information to the event here, because in Solidity, of course, it's extremely easy to get the time. It's just now, the keyword now. So what we could do is we could just make this event explicitly log the time. I think I'm going to do it. I'm a little reluctant because then we're sort of adding logic to the contract, just because we can't, because the interface doesn't, isn't intelligent enough. It is not intelligent enough to easily translate the block number into a time. But I would like to move on, so I think I'm going to do that. So we have the agent, the action, and then we're going to do uint time. And then here we're just going to pass in now, just like that. And now we're going to have to redeploy this, and so we'll have to re-upload all of, give it the new contract info, and we'll also have to repopulate it with some events, but that's okay. We'll just do it. Okay, now while it's compiling, or deploying rather, get the ABI from here, just in case it's changed. I'm just curious to see. It probably changed a little bit. Let's see. Yep. So you can see that you can see what's changed there is our definition of our punch event. So that's not too unexpected. And then we'll need to put in the address when it gets mined. Maybe it's a mined already. That'd be cool. Let's see. Indeed it is. That's nice. Okay. Grab that contract. No, that seems to be something else. Did I well, maybe I didn't actually click. I think I just didn't click deploy yet. Silly me. Right, because that one was a while ago. Okay, that's weird. My MetaMask is not showing me that those new transactions that I just did. What is going on? Maybe my remix is using a different, oh, it is using a different account. It's using Alice, which is bizarre because I'm not logged in with Alice. I'm logged in with my main, but I guess this is selecting Alice. So, and here are yeah, here's 2 deployed contracts. So they're deployed by Alice, but I guess that's fine. I'm just going to copy that address and put it in here so we have it up on Etherscan. There it is. And I'm also going to close all these old, any of these old tabs here. Okay, well, we got the contract. Okay, let's take this. Let's go to our code, slap it in there. Now, our event should now have that that information inside it, the time as a uinteger. So we can say, okay, now we're ready to iterate through. Grab that time and use that to calculate the hours worked. So hours, and actually let's just make this seconds worked because that's how we'll be. That is the unit we'll be grabbing it from, and then we're going to say for. Take out this line. Length plus and so I guess we're going to be sort of toggling back and forth between the in and the out, and the in and the out. We want to, if we get 1 in and 3 outs, we would want to ignore the successive outs. And similarly, if we got 3 ins in a row, we'd want to just get the first one. So we need to keep track, I suppose, of whether we have gotten an in of our in action found equals false. Var out action found equals false. Okay. So we're going to say if no in action found, if and no out action found, then we want to look for the first in action. So if let's see, we don't need to app.punch actions. I guess that's fine. It just seems like a lot to type every time. Actions dot I dot args and then time. Okay, we need to put some parentheses around this. Oh wait, no, we're not going to test for time. We're going to test for action. Equals in. Action found equals true. And then continue. So we start. And then we're also going to say var in time. Start it with 0. And we'll just leave it like that for now. And then we'll need to set this in time. I'll make this clearer by saying in action time. It's a better name for this. And then here, so okay. Window.app.punch actions I.args, and here's where we use that time, just like that. Okay, and then this continue will start to loop over. So if, let's get out of this, if, else if, in action found, and no out action found. So if we found an in but we haven't found an out yet, then if window.app.punchActions I.args action equals out. Then out action found equals true. And then now we can get the time. Window.app.punch actions args time, like that. Okay, so now we have the in time and the out time. We can subtract them and finally add them to the seconds worked variable way up here. So so now, what do we want to do if they've both been found? Actually, well, okay, first of all, continue here, and then I'm just going to say if at the very top of this, if they've both been found, in action found and out action found, then we want to sort of reset everything. So we're going to say in action found equals false, out action found equals false, and in action time equals 0. Okay, so first we'll trigger this on the first in, and then in action found will be true, and we'll log the time. Then once it finds the next out, it will do the subtraction and add that to seconds worked. And in the next loop, it'll notice that the in action found and the out action found are both true, so we'll reset everything and prepare it to do the same thing. So that should work. Let me just check some messages here. Oh, well, that's true. Yeah, so I guess it depends on what we want the behavior to be. If you clock in once and then clock out twice, how should that be handled? I mean, it's hard to... I have trouble deciding whether one should be, do we want to assume that the last clock out is correct, or is the first clock out is correct? I don't really see any reason to choose one over the other. If you have a better thought on that, let me know. For now, I'm going to keep it as this. I mean, if you're an employee and you go to a time clock and you punch in and then later you punch out, why would you want to punch out again? Maybe it was a mistake to punch out in the first place, but then I think you would just punch right back in. So I'm going to keep it as it is, the logic as it is right now, unless you have another reason that it would be better, that it makes more sense to interpret the last punch out as the correct one. I'm just going to keep it as it is for now. Okay. So that logic is sound. Of course, we haven't actually tested to see if we can actually find the time in the args, but I'm just going to run it and see what happens here. So we need to refresh to get my address again. Nope, not there. Okay, it's logging an empty list. Let's see where that log is. Oh, we don't actually do anything with this variable. We just added to it and then we didn't do anything. So let's see. Now this is all... This is not in the callback, so that's going to fail. Let's take take all this, cut it and paste it and put it in the callback here. That's one thing. So it's in the callback. And then we want to actually do something with the seconds worked here. I am going to just add another variable to our app here, and that is hours worked 0. And then at the very end here, after all of our loops, I'm going to say hours window.app.hours worked equals seconds worked times 60 times 60. And I'm just going to make sure those are going to be floats. Okay, so now it won't display anywhere, but it should at least store it, and we'll be able to check it in the console. So let's try that again. Is my address? Nope, it's not. Okay, I have to get my address. Second worked. Oops, forgot the S. I got a comment. Divided 60. Oh, you're right. Yes. Divided by, that's a good catch there, and I'll just do this. Divided by that number there. Yes, indeed. Okay, that's good. Fix 2 bugs that way. Okay, let's comment, or let's paste. Get punch events. Okay, now it should have saved that. Let's see. Window.app. Hours worked. 0. Oh wait, did I? Oh, I don't have any events on this yet. I redeployed it and I never populated it with events, so that makes sense. Okay, so I'm gonna refresh this because it's still making me do stuff with Alice. Let's copy the address here. Okay, now refresh and reload. And actually, I really should load this in Pragma, because it's a better interface for when you actually have a contract that exists. Come on. Okay. Let's see. Contracts. That existing. Here's the address. I'm going to name it punch clock, and we'll have to delete the old one as well. Oh, that's interesting. There's no semicolons here, but it was loading the stuff anyway. I guess that's JavaScript. I guess JavaScript just does that. Okay, submit. There's our new one there. I'm going to delete the old one. So we don't get confused. And now interact here. And okay, so let's do this and submit. Now, gonna have to unfortunately wait a little bit for this to mine. That way when we send in our clock out action, it'll be in a different block and therefore have a different time. We'll put this in here and then we'll wait for this to get mined first. Oh, it's been included. So, okay, I guess we can already go now and just go out. Submit. Let's see about this one. Okay, so now we got an in and an out, and they should have different blocks. Yes, indeed, they're 2 blocks apart, so that should give them different time values. So let's just click this again. There we go. So we got some more information here. Once again, let's check the hours worked. Hey, there we go. So we got a little tally going on there. 0.008 hours worked. That's cool. It really should be tested a little bit more, just because this logic here, I threw it all together all at once. So and it's a little bit non-standard. So who knows really if that works completely, but certainly that seems about right. That seems like I would have the time between these two transactions is 0.0088 whatever, almost 0.01 hours. So that's cool. Let's go look at our outline here. Yep, we're effectively doing that, although I'll probably reword what we really did there. And then here we can do this. Really, this should be tested more, but I think I'm happy with that. I mean, I guess I'll keep this tab open. I'll do an in right now, and if I remember to later, I will do another out one, and we'll just make sure that it works with more data there. In fact, I'm just going to do a bunch of ins right now, just to see if tons of ins messes it up. And why not do a weird one? Okay, and later, I'm going to put it in now. I'm not going to run it. Later I'll hit submit after some time has passed. Okay, but that's cool. We have this ugly interface. It could use some visual massaging, but I'm not going to worry about that now. That could be for a Friday activity. Let's look at. Okay, so now this number 2. We've been using Pragma to do the clock in and out, and we have to type in or out. So we're going to build a Python script it'll offer 2 functions, clock in and clock out, and it'll automatically sign the transaction and actually do the action here. We have about 23 minutes left in the seminar. We're going to start it with just a hard-coded private key, and that is just to make things simple. The nice thing about Python is you can handle the private keys directly, and that's good because then you can execute transactions without having to ask the user for a confirmation and without having to rely on some outside system or process to sign the transaction before you can send it. So I will at least show you guys how to do that. And then if we have some time, we'll talk about or work in other methods of generating, loading / importing a user's private key. So the first thing I should do is just grab I'm going to generate a fresh private key. And for that, I'm just going to Google Ethereum Brain Wallet. Maybe my crypto will do it. I'm sure it will. Let's see, create new wallet. Oh man, is it not going to let me? It's not just going to give me the private key directly. What about my Ether wallet? Maybe that will. No way. New wallet. Here we go. This looks like this will do what I want. I'm just going to enter, I guess, a stupid password. I understand. Download. Okay, so there's a key store file. Here's the private key. That's what I want. I don't even need the file. So obviously I'm streaming this, so I'm not going to be putting a lot of money on here. Well, I'm not going to be putting anything on there except for Ropsten Ether, but we have a private key now. So I am going to go over here and go to our Clock Punch Pi. So this is a lot of the same code we had from yesterday. For those of you that were here in the video or in the stream, we're not looking, it's pretty much the same up to line 12 here. But after line 14, previously we tried to do some event stuff. We're not going to be doing that. We're just going to be trying to send a transaction. So there's our private key, like that. And what we're going to be using is a particular part of, let me just close some of this stuff. We're going to be using a particular, oh wait, you know what, I wanted to keep that open. It's probably going to go away now, because that'll give us the address and stuff too. But let's see, Web3 Pi docs. I just want to show you guys the specific part of this library that we're using here. Because there's two ways that you can, see, there's working with local private keys, and that's what we'll be using. You can also do the personal API, and that actually will outsource that actions to your node. I used to try to do it in that way, but that, if you're using QuickNode, for example, QuickNode will, by default, disable that because it's a security issue. They don't want to be holding private keys. So this way, if you work with local private keys, you actually don't even need a node technically to broadcast it. You could generate a transaction and sign it and then upload it to Etherscan, for example. But that's what we'll be doing. So yes, let's get down here. Well, I don't think I really need to read this. I have an example file I'll be using, but I will take this link and put it in the post here for you guys later. So yeah, I'm just going to close this because, as I said, I'm going to be using an example. A file I've used before. Let's see. GitHub, crypto primitive. Okay, contract function call. That's what we're going to be doing. I think I'm also going to need the, so here we use the private key. This is the line we'll be using. Web3 ETH account sign transaction. You give it a transaction object, which we'll build, and then you give it a private key. And that's all you really need to do. Although another thing is that to generate part of this transaction object, you need to give it a nonce. And to do that, you need to give it the address of the private key, the address that goes along with it. And that way it can look at the address on the blockchain and see what nonce it's supposed to add in there, because of course the nonce is different for every transaction an account will sign. So now in this file, I get the address programmatically, but just to keep things simple, I'm just going to go to my Ether wallet, and I'm going to say view wallet info, and we're going to put in the private key. And is it still in my, nope, it's not. Let's go grab it from, here it is. Okay, put the private key in here, unlock. There is my address. So I'm just going to take this and hard code that as well into our program here. Like so. Oh, we don't need semicolons. This is Python. Okay, we got a private key and an address. So value 0 nonce. We're ready to. So that I just put this stuff in here earlier, but this is how we'll make the transaction here. Let's go back to the example and see what we did to get nonce specifically. Yeah, nonce equals web3.eth.get transaction count. Web3. And actually w3.eth, because that's what we call it in this file, .get transaction count. And let's make sure I did that right. Yep. Then just give the address. Okay. Chain ID, we're going to put 3 in here because it's Ropsten. 1 is mainnet, so that's why that 3 is there. I could put a comment there. Equals Ropsten. And then gas price, that we're just going to put it 20 gigaway, and to do that we need to use web3.to, let's see, w3, I believe. Yeah, just two-way. Two-way, and then we give it a number. Then we give it what we're translating from gigaway. That's how the gas price is usually denominated in gigaway. So we need to translate the 20 gigaway to a number of way, which is huge, a huge number. That looks good. Anything else? Nope. And then we need to estimate the gas, which I have down here. So we're adding a gas item to this dictionary, and here we're going to, now in Python, I don't think this actually calls the function, just sort of prepares it. And so, yeah, so we need to, this is sort of a general form, which is why I keep having to look at it. But as you can see, we can pass in the argument that we want it to use. And in this case, we're just going to say .estimate gas. And I'm going to multiply that by 2. That's what I had to do last time. Sometimes that when you estimate the gas, it seemed to be too low. Then we can build a transaction after that. And I don't keep forgetting I don't need a semicolon. But let me see what the message is here. Line 20, a comma is missing after chain ID. Thank you so much for that, Seyron. Okay. Then, okay, so yeah, now we need to build the transaction. And to do that, we say, now a weird thing is that I'm building this dictionary object right here. And then I'm assigning to that same object the result of this. I guess I don't really want to do that. I mean, interesting to note that that works. It just sort of gives you a fuller dictionary, but just for clarity and cleanliness, I'm just going to give it another name. Okay. And then I think it's just build transaction. Okay. Now we still need to sign it, which is pretty easy. I think it's a count. Is that the name of the? Yeah. So the count is the name of the. It's like the namespace of our private key handling and manually signing functions. Is that right? Yep. Sign transaction, and then we need to give it the transaction and the private key. So. Transaction and priv, and we can store the last transaction. We can store the hash from it if we want, but let's just send it. We can print. We'll just do a print for now. Well, we can return it. How about that? So this function, our clock-in function, will return the transaction ID, and we'll print that when we call it. Web3 ETH send raw transaction. I think that's it. I think signed dot raw transaction. Okay. Okay, so we've defined our function now. Print. So this should now print the transaction ID of this whole process. So let's just see if that works. This will send a clock in from this address here, so our interface won't we'll have to plug this address into our interface to actually see it. But first we'll just run this and see if it shows up on the blockchain. So let me get a Python prompt going. week 4 clock punch pi. That's where we are. And I need to use Python 3. Web 3 is not defined. Oh yeah. W3. Now it is a bit weird that I'm using W3 here and Web3 in JavaScript. Part of that is because there's some weird naming conflicts with the name of the module. I mean, it's just a bit weird. But anyway, there's probably a better, more elegant way to do it. I don't do it. Oh, we also need to change the ABI and the address, right? Oh, I hard-coded the address. Yeah. Let's do this. I'm going to make a new file here. I'm just going to, I want to contract info.py. I want to collect this. So this can all go in here. Whoops. Now this is going to define an address and an ABI. Let's do it like that. Delete this. Now contract info.py. Be cool if we get the ABI itself in this file, so we don't have to paste things in two different files. So I'm going to change that as well. And this ABI is outdated anyway, so I'm just going to close that and actually delete this file. Move to trash, and then contract info. And say this. Okay, now we just need to paste the ABI in here, so let's go grab it. Let's grab it from our file here. In fact, let's, well, okay, there, like that. Take out that semicolon, and we'll actually call this ABI string. And then we'll move the address assignment up here as well, and erase it from down here. And change this ABI to load not from the file, but from our string, which is json.load s ABI string, like that. And all we need to do now is put the address in here. So let's get that again from our JavaScript interface. Paste that there. Okay, so now we have the new address and the new ABI in here. It's taking the ABI string and loading it into the ABI, which again, that's a step you need to do in Python because it's this is in JavaScript, JSON, which stands for JavaScript Object Notation. So you need to actually do that step of translation. Any case, let's get back to our clock punch pi, which is importing ABI and address from this file we've just built. Let's just make that explicit, like that. Okay, now it's going to make a contract out of the ABI and address, which is fine. Although, oh, we have a naming conflict here. Let's, whoops, no, we want to keep that the same, but we have a user address now, and we have a contract. So let's just change that. And actually, this should be clock punch address, clock punch ABI. And I'll change that in the, dang it. Change that in the other file in a second. Punch address. Okay, change that up here. Okay. All right, so we have a user address now and a contract address. We also have a contract. So let's run that now. JSON is not defined. I need to import JSON in this guy. Try again. Name address is not defined. Okay, so I didn't. It's on line 18. Yeah. User address there. We're getting the nonce of the user because it's the user that's creating this transaction, building it. Yep. I just yep, that's true. Okay. Invalid sender. So that's line 29 is eventually returning with an invalid sender. Invalid sender. Let's print raw transaction, see what we see. Let's see what we get from these guys. So that first bit there is our built transaction, which looks fine, although there is no from. Built transaction. Let me go look at my reference that I was using. Contract. Value, nonce, chain ID, gas price, gas. We don't seem to specify the from in this one, but let's just make it explicit. So this dictionary has a from. We can have a from key in here. So let's just see about changing that. Invalid sender, it tells me. Oh, well, one thing is this guy has no money yet. And maybe that might lead to an invalid sender. So I should have done that before. Let me just fund this guy with a little bit of Ropsten ether, because that I can see that maybe triggering that weird error. Oh, we're almost out of time. Let's very quickly send this guy 0.1 ether. Next. Come on. Next. Submit. Okay. So yeah, it's we're just about out of time. Let's what's the last thing that we can do? So when that gets mined, we should be able to run this again, and it should actually clock in for us, and then print the transaction ID. So hopefully it'll work here. Just wait for this guy to mine and try it out. I'm also going to take out this from, because I don't think that's necessary. It didn't solve our problem in any case. To give it a gas price and a gas, and this is an annoying vagueness. This is gas limit. Gas price is gas price, and when you are setting it the gas key, you're setting the gas limit. Oh, no, this is interesting. The gas price was reset to 1 gig away, which it looks like the built transaction overwrote that. So I'm just going to say do that. Is this mined yet? It did. Okay. Well, that's good that it mined. So now that we've sent Ether to this address, and I've also increased the gas price, which that wouldn't have given us an error, but it should have stayed 20. So let's run this again and see what happens. Invalid sender still. Interesting. Yeah, this transaction that we're looking at is just the MetaMask transaction to fund my new address here. So now that that has completed, we see that our new address here has 0.1 Ether. It's interesting. Okay, well, let's just 2 minutes over. I'm gonna do a quick search and see if there's maybe a quick answer to this error, invalid sender. This is not really helpful. Web3 ETH sign transaction, and there's ETH transaction sign, and I guess that one fails. Am I using this one then? That's weird. I'm using a third, completely different one. Jesus. Well, I guess the ETH transaction sign is probably assuming your node has the key. These are all old. Solved by changing the chain ID. Our chain ID is 3. Oh, you know what? Our node is on mainnet. This node that we're connecting to is on mainnet. So I'm signing a transaction for Ropsten, but I'm sending it to a node that's on mainnet. So that's the problem, I suspect. I suspect that so this address, and I think that sort of makes sense. So the error we're getting, I'll just explain this and then end the seminar and work on resolving it myself. But the error is invalid sender. And it's probably saying that because we have a user address that has an account on Ropsten, but not on mainnet. And we're creating this transaction as if it's a Ropsten transaction, but then we're actually sending it to a node that's on mainnet. So the mainnet node looks at this transaction, looks at who it's coming from, and it says, well, that account doesn't exist on the network because it's looking at the mainnet network. So I guess I'll end the stream here, and I'll keep hammering at this. And if I get something working here soon, I'll just upload another video at the end, just demonstrating the usage of this function. But I'm pretty sure that's the problem. We could change this to 1, of course, but then we'd have to redeploy the contract on mainnet and repopulate it, or well, at least, well, anyway, there's a couple different ways we could address this problem, but I'm sure it has to do with the fact that our node here is on mainnet, and we're building a Rhapsody transaction effectively. All right, so that's it for today's seminar. Thanks again, guys, for tuning in. Yeah, hopefully I can get this fixed and upload a video. Let's see. So tomorrow's Thursday, and we got Thursday and Friday, each going to be an hour long. I'll probably just keep on with this work on Thursday, the interface work here, focusing again on functionality, see if we can move to proof of concept. And then on Friday, we'll try to make the thing look pretty. So that's the plan. Thanks, guys. See you next time.